All right, so we are going to start talking about angle proofs, and we're going to realize that we're going to use all of these other properties that we learned before, these properties of equality and these properties of congruence still apply to angles as well. There's some definitions that also work for angles, and we're going to review some definitions here. So first, we got that definition of congruence. That's when I go from equal to congruent, but obviously here I'm using that angle notation. That little m represents the measure of angle A is equal to the measure of angle B. Remember, that's when I'm talking about actual numerical values. If I used a protractor, they would be equal and also congruent. So remember that here, if this is angle A, this is angle B, I'm looking for those congruent markings like this. Okay, and if they were both 40 degrees, they're equal in measure as well. An angle bisector, this is going to come up a lot, and we're going to use that definition of an angle bisector, and it splits it into two equal parts. Okay, so kind of how like the midpoint acted with segments, angle bisectors are going to split those two angles to be equal. Next, we have definition of complementary angles. We know that in order for them to be complementary, they have to add to be 90. Okay, definition of supplementary, they have to add, two angles have to add to be 180. Definition of perpendicular, this is kind of a recall things that you learned before, is two lines that intersect and make 90 degrees. So these are perpendicular. The little symbol for perpendicular is this like upside down T. That's the symbol for perpendicular. Okay, if you guys see that along the way. Definition of a right angle seems silly, but if I know something's a right angle, I know that its measure is exactly equal to 90. So it seems intuitive. It seems like we wouldn't even have to add that to a proof. But remember, we're thinking about every little step we take. We have some postulates and theorems. Some of these are old, and some of these are kind of new. So you definitely want to pay attention to the last ones here. But angle addition is when the two pieces add up to be equal to the whole thing. Remember, it doesn't say anything about bisector. Be careful to not assume that unless you're told. Next, we have vertical angles. We know with vertical angles, when I have two lines, that these angles are congruent as well as these. Okay, all vertical angles are congruent to one another. Complement theorem here, if two angles form a right angle, then they are complementary. Seems kind of like that makes sense, but that's kind of this situation here. If I have this angle plus this angle, it'll be equal to that 90 degrees. All right. And then supplement theorem. If two angles form a linear pair, then they are supplementary. I've kind of heard of this as the linear, and our book might say linear pair postulate. Again, this is kind of what's weird is some geometry textbooks use different language for the same thing. As long as you describe it to me too, I can handle it. If two things are a linear pair, remembering a linear pair are two angles that have this adjacent side, and this plus this angle form a straight line, meaning they add up to be 180, which means that they're supplementary. All right, new ones. These are pretty new. These two next theorems here. The first one says if A is complementary to B and C is complementary to B, then A and C both have to be congruent. Okay? So if we know, say we know let me draw this. Or let me just say, if I know angle B is equal, the measure of angle B is equal to 40 degrees. The measure of angle A would have to be equal to 50 degrees. Okay? Right? Because they're complementary. Now, if the measure of angle B is equal to still 40 degrees and it's complementary, right, to C, doesn't C have to be 50 degrees as well, making then C and A equal to each other or congruent. Okay, so this I kind of think about as like kind of like the transitive property with complementary angles. If they're complementary to the same angle, then they're going to be equal. Same thing with our supplementary, congruent supplements. Here, if A is supplementary to B, C is supplementary to B. It's kind of like that transitive property, but now it's like A is now equal to C because B's value is going to stay the same. And to be supplementary, you have to add up to be 180, so A and C have to be the same. All right, you can make up some values again. You can say A is 120 degrees, which means B would have to be 60. So if B is 60 degrees, C also has to be 120 degrees, making them congruent. Okay, so again, some things that probably seem intuitive, and now we have these specific names for them. Okay? So what I would like you guys to do right now, which would be ideal, is to kind of pause and work on this or save it for after. I think a lot of these are straightforward. It's just reading through this and then naming the properties from the front here using all of our properties from before, and all the ones I just highlighted are going to be the ones you use. Okay, so what you guys are going to be asked to do next, we're kind of leading up to doing a proof. And now it kind of gives you a definition or a theorem, and it's asking you to complete the statement, which I think is really good practice for us with proofs right now. So if I'm talking about definition of congruence here, and I'm told that they are congruent, what's my new statement going to be? Well, then I know the measure of angle D is exactly equal to the measure of angle E. Remembering definition of congruence kind of goes from congruent world to equal world and vice versa. All right. So definition of complementary, well, if these two angles are equal to 90, then I know angle 1 and angle 2 are complementary. Simple as that. Okay. Maybe I'll skip to number 5 and you guys are going to kind of work on this. Oh, this one's silly, right? Number 4, actually. If I look at 4, the measure of angle JKL is equal to 90 degrees. Then obviously, angle JKL is a right angle. I know you're probably annoyed that this seems very obvious, but let's just, go with it. If angle 3 and 4 are vertical angles, then I know that they're congruent. You could also say that their measures are equal. I'm never going to take points off for you guys saying one thing incongruent, one thing in equal. Usually, unless the proof asks for something specific, if it asks for it to be congruent or if asks for it to be equal, just pay attention to that. Okay, so you guys kind of trying to fill in the rest using your theorems. But I'm going to do one proof with you, and then you're going to spend the rest of the time, practicing your proofs and things like that. Okay, plenty to do. So here, we have this given, okay? We know 1 and 2 form a linear pair, which we can see there, okay? And we know that 1 and 3 are supplementary. So now I'm proving that 2 is congruent to 3. All right, so obviously this is kind of a lengthy proof to kind of go step by step by step. So let's start with our givens. Okay, so I'm given that angle 1 and 2 form this linear pair. Well, if they're a linear pair, right, because I'm using this to this, if they're a linear pair, then they're also supplementary. And I know that by the supplement theorem. I was about to say that linear pair postulate. Ran out of space. Okay, either one. On here it said supplement theorem. I just think about big ideas, says linear pair postulate. They both say the same thing and I would accept either. So, okay, if we have a linear pair, I know they're supplementary. What do I know about supplementary now? I know supplementary angles. Okay. Okay, well, I think my pen died. So I'm not restarting this, so you guys got to hang with me here, okay? So now you got to listen, which I know can be hard to do. And we'll see if I can charge my pen for a second. So if I know that 1 and 2 are supplementary, I know that they add to be 180. That is the definition of what supplementary angles say, okay? They're supplementary, they add to be 180. All right, charge it for a second and we're good. Okay, so definition of supplementary angles. And I like to do this little angle symbol. Okay, so that kind of helped us with the first part. We were given and we kind of ran with it. Now we were also given that 1 and 3 are supplementary. So, right, I was given this here, we kind of ran with that. Okay, so what do I know about supplementary? Oh, I know they add up to be 180. So I got that definition of supplementary angles again. Okay, now I know both of these, okay? Now I gotta remember my goal. My goal is to say that 2 and 3 are equal to one another. All right, well, I know that 1 and 2 equal 180 from line 3. All right. Okay, I know 1 and 2 equal 180. And 1 and 3 equal 180. So now I can set them equal to one another. That's going to be either, you could say, transitive property of equality, or I would accept substitution. Okay, since they're both equal to 180, they're equal to each other. Now I see I have this measure of angle 1 on both sides, and I'm really close to having that measure of angle 2 equals 3, which is my goal. So I know because it's on both sides, I can use that subtraction property of equality. And I change it to from here to here, right? I change it to congruence, which is the definition of congruence. Okay, so again, you guys can use highlighters, you can do this, but it's really like, okay, based on this given, what little steps can I go? And not forgetting about what your very end goal is. Knowing that this proof kind of tells a story from beginning to end, not that every line stands on its own. All right, what you guys can do next is work on the rest of these proofs and check with my answer key online. Good luck, and you got this.